Welcome, everyone. Welcome back to class. Third week, big week. All
Yeah,
right.
thank you so much, Martha, too, for mentioning the note about daylight savings time. That was
That's
key.
very good to know. All right. Since we have lots to get into today, we'll go ahead and get started. Can everyone see the screen okay?
Yes.
All right. So welcome again, and thanks for coming back to the third class. We only have one class left after this. So we are excited to dig in today, and we're gonna get into growing, harvesting, and retting with our two guest speakers today, Maciej Kowalski and Cody Ley. And then next week for our last class, we will do more on retting, processing, and end uses. And as a reminder, one certified crop advisor credit can be earned each class session. If you want to apply for CCA credits, we will show a QR code at the end of class, and you can learn more about that then. And of course, we want to thank our funder who makes this work possible. This work is funded by the Agriculture and Food Research Initiative CARE Grant and the SUN Grant Program from the U.S. Department of Agriculture's National Institute of Food and Agriculture. And again, as a reminder, this course is hosted through the Extension Foundation Campus online course portal. If you haven't enrolled yet, go ahead and scan the QR code, and we'll also put a link in the chat where you can enroll for free in the course and get access to all of the course materials, including recordings of class sessions in case you miss one or want to look back at a previous class. There are also more videos, guides, and other things that can support your learning throughout this class on the course portal. And now we'll get into the presentation. We have lots to get into today, so I will toss it over to Laura.
Thank you, Shannon. Just getting set up here. Great. Okay. I think you all can see that. So welcome to class, everybody. Thank you for your attendance. Your presence has been such a gift, and it has been truly inspiring to gather together the last couple of weeks. You guys have been doing a really great job of reaching out to Shannon whenever you have any questions about viewing the previous modules, and that's all awesome. Today we are on our third module of the fiber hemp production short course, and our topics of the day are growing, harvesting, and retting. And here's our agenda. We will start the class with our poll and a recap. Then we will revisit flowering and maturation. After that, we'll talk about harvesting and retting methods. And today we have two guest speakers for you all. First, we'll hear from Maciej Kowalski about his hemp clothing farm and brand in Poland. And after that, we will talk with Cody Ley and hear about his work growing for building materials in Michigan. Maciej will not be able to join us for Q&A, unfortunately, as he is currently on vacation with his family, but we are very lucky to spend our live discussion time with Cody and ask him all about growing for building. And here's our poll question, you guys, and I'm sorry, this is a hard one. We have not learned this yet in the course, but it's important for you all to know. So just take your best guess. When should you schedule a sampling event for your crop? And this is when your crop is tested for THC. Is it when you see the first male flowers, when you see the first female flowers, within 30 days of your harvest, or within 80 days of planting?
What was the second to last option?
The second to last option is within 30 days of harvest. And I just ended the poll. I'll share the results with you all. The answer is within 30 days of your harvest. And you will find a sampling agent through the Hemp e-management platform that we talked about. This is someone in Vermont who will come and take a sample for you and send it to the nearest cannabis diagnostics lab. I think in Vermont there is only one. And just to give you guys a better sense of what compliance will look like for you, realistically, you'll probably only have to visit the website platform 3 or 4 times in a season, but this will definitely be one of those times. So I guess my advice is make sure you write down your passwords for the eHemp management platform site, because it's not something you're going to be visiting too frequently. Okay. And moving on to our recap from last week to jog your memory. Last week we talked about planting and planting systems. You're going to want to order your seed from January to March, so about now. When calculating your seeding rate, the very first question to ask yourself is, what is my end use market? You're going to want to plant earlier to avoid major weed issues. You're going to want to scout your crop for emergence within 2 weeks of planting. And you'll need to know 2 things about your hemp seed in order to increase the accuracy of your seeding rate. Those are germination rate and 1,000 kernel weight. Planting depth is 0.5 to 1.5 inches. Row spacing for fiber hemp is 2 to 7 inches. And if you find something unfamiliar to you, whether that's a weed, a disease, or a pest or bug of some kind, you can send specimens to the UVM Plant Diagnostic Clinic and get to know your crop by scouting for the first signs of flowering. So as I just mentioned, you're going to want to be out in your field scouting for flowering or maturation. Keep in mind that male and female hemp flowers mature at different times, with male flowers expressing usually 2 weeks earlier than their female counterparts. So I want to make sure that we all know what this looks like in the field, because while we all probably know what female hemp flowers look like, it's possible that many of you may have never seen a male cannabis plant. So we have a couple photos on the left, and on the right we have this video. And this is a variety called Indigo that we grew last year, and it's very pretty. It has purple flowers and green leaves, as you can see. And you can also see the male and female plants look quite different. So there isn't a great risk of mixing them up. And again, this is important because flowering is likely going to be the first signal you receive pertaining to harvest timing. And I would not yet call this moment in the video peak flowering, because I can see some female plants that aren't quite in bloom, but hopefully you can see that the male flowers are totally open and therefore dropping pollen all the way around. So that's what that looks like. And again, this is called Indigo. It's a very beautiful variety. It's kind of more of a grain variety actually, but we put it in both trials. And here are some more up close looks. I didn't have a great photo of a monoecious variety, but this one should suffice. And you can see that I've circled the seed that is forming in purple. So anytime you have a seed, you for sure have female anatomy. And you'll also notice that I circled some little brown hairs in red, and those are called pistils, and those are female flower reproductive organs. So also anytime you have little brown or white hairs, you'll also have female flower anatomy. The blue circle is showing us male flowers. And whenever you see a little yellow or white flower or bud on a hemp plant that looks like what we would consider a more traditional flower, that flower is a male. So hopefully you can all see that there. And let's zoom out for just a moment, pun intended. 2 weeks ago, we talked about preparing to plant. And then last week, we talked about planting systems. And I wanted to highlight something very important that Steve said. and that was once your crop is about 6 inches tall, most of the work of growing is done. And I would agree with that. Hemp grows relatively quickly, and once it is established, you will have about 60 days at least to enjoy the fruits of your labor and watch it grow. But before you know it, it will be up over your head and you'll be wondering when it's time to harvest. So maybe you remember that I told you that hemp is quite flexible, and there are actually many ways to grow it. You can harvest as early as 60 days, or you can harvest it dead after winter in April. And actually, one of our guest speakers today does it this way. So I hope you're all getting excited because we're going to talk about all of the harvest methodologies. And I really want you to think of hemp as the plastic of the future, and not plastic as a kind of bad word, but instead in reference to the plasticity with which it can be adapted for various uses. Okay, so with all of that said, let's get back to our regularly scheduled programming here. Growing, when to harvest. Harvest timing will depend on end use. For high quality textile spinning, you're going to harvest right before any of the plants have expressed their flowers. This usually is around 60 to 70 days. And this is when the crop will be the most uniform and consistent. But harvesting at this time will result in an overall reduction of yield as plants have not fully matured. So line fiber is like a premium product, and you would ideally get paid a premium for it because your overhead expenses are going to be greater because you paid more for seed and in the higher seeding rate, and you're going to have a lower yield than you would if you let it grow out. But it makes sense if you think about it because most plants, they grow in spring by first putting energy into the stalk. And by the time that a flower is forming, the plant's energy is going to be going to the flower, and the stalk is going to be drying down and toughening up. So that's why line fiber is harvested at that tender stalk stage, ideally. For biomass or herd material, the general goal of harvest timing is to find the window when maximum fiber yield and quality intersect. And this would occur around peak flowering, so about 80 to 100 days, but before seeds have set. For dual purpose, which means fiber and grain, you would want to harvest when 70 to 80% of the seeds are mature, firm, and brown. And this would be likely at 100 plus days. And for winter retting, you would harvest in the spring when the temperature is warming up. And for us in Vermont, this is mid to late April. So winter retting, we've mentioned it a couple of times, is what it's called when you let the plants stand dead through winter and harvest them dead on the other side of winter. And we will get into that some more on another slide. So harvesting, if you're going to harvest in season, which means everything except winter retting, harvest method will also depend on end use. It's important to note that hemp-specific harvesting equipment is not currently widely available in the Northeast. So on the research farm, plants are cut with a sickle bar, and we made one that attaches to our skid steer, and they are cut roughly 4 inches from the ground, and they are then manually lined up and laid on the ground to ret. And we do this by hand. There is equipment in Europe that does it by machine. And our end use goal is the long line artisanal fiber. For other folks who are growing at a large scale for biomass production or cottonized fiber, they can utilize a harvest protocol that closely resembles that of a hay crop. And this crop would be cut with a disc cutter and then raked periodically until it reaches 15% moisture before baling and storing. Retting. Retting is the step that comes after harvesting, except in the case of winter retting. And there are several ways to achieve retting. The goal of retting is to dissolve the natural glues that bind the bass to the herd in order to make their separation possible. So field and water retting are microbial processes by which microorganisms colonize the stalks and eat the pectin and lignin that bind the bass fiber to the herd. Winter retting is a mechanical and perhaps partially microbial process in which stalks are left standing dead through the winter. Freezing and thawing temperatures then weather the stalks and break down their gluey constituents. Chemical retting, we're not going to talk so much about, but it is also possible and it's widely practiced in China. And whether harvesting for bass or herd, retting is applicable as it will loosen one from the other, and most all end-use applications will require their clean separation. So in the previous slide, I mentioned field and water retting together. And we're going to skip over water retting because we don't have much time, and it's also banned in Europe as a practice, and maybe in other parts of the world too. But basically, it involves submerging fiber in water, and the resulting water gets very deoxygenated and becomes a biohazard. So we're not going to spend our precious time together on that right now. And instead, we're going to focus on field retting. Field retting is also called dew retting, and it begins as soon as the plants are cut and laid on the ground. In the Northeast, this process typically takes 3 to 4 weeks, but the process is entirely contingent on temperature and moisture. Stalks must be flipped over once a week and with greater frequency in the event of rain. I say if you have a rain event that's bigger than 1 inch, you're going to want to flip your retting piles. And once moisture is under 15%, the retting process will cease. But that percent moisture is not stagnant. It's going to also depend on what the weather is doing. So you don't want to bale your crop before it is below 15% moisture, but it might reach 15% moisture and then get wet again and keep retting. So that is not, that doesn't mean the process will end permanently, I guess. And before the retting process is complete, the green coloring in the stalk will fade to brown or silver. Black flecks on the stalk are normal and will increase with increased moisture. So after doing this for a number of years, it has become one of my favorite ways to connect with the earth. And I think of retting as like the original magic. It's literally like a slow pan fry on the surface of the earth, and there are no other ingredients necessary. It also represents the moment where the plant material transitions into raw material. And it's been so cool and humbling to learn it all over again, year after year. And maybe you notice I use the word humbling because field retting is finicky and you don't have much control at all. In a dry climate, stalks risk drying without retting, and in a rainy climate, you can get very uneven results. But that said, retting is very important for now, and in the future, we might see more breakthroughs in decorticating material while it's still green. And this is something that Steve mentioned to us last week that he is working on. So all of the techniques are always evolving and emerging. And here's just a quick slide to show you some of those stages of retting. The T colon here represents weeks retting. So we have 0 weeks, 2 weeks, 3 weeks, and 7 weeks. And you can see the fiber really pulling off the herd after 7 weeks. And we would call that over-retted. And so unfortunately, we don't have time to watch this video together as it's about 6 minutes long. But this and multiple series of videos on retting and winter retting can be found at our UVM Extension YouTube page, which is linked in your course notes. So I highly recommend you all take a look through what we have there if this is interesting to you. And now we'll just talk about winter retting. Winter retting is really promising and exciting because it slows the whole retting process down a bit, which is sometimes what we need when we are researchers trying to understand the secrets of the universe. Winter retting can be utilized in lieu of field retting instead of relying solely on microbes and moisture. It uses mechanical action of freezing, thawing, and wind to mechanically separate vast from herd. Winter retting is only possible in regions that reliably see freezing temperatures throughout the winter. I included an asterisk here because that's what I was taught, but I've actually heard of people doing it in other regions. So if that's you and it's something you'd like to try, you should do some research on that and definitely give it a try. Just leave a little plot standing and see what happens. The crop is then harvested in spring once the weather has warmed and the fields become accessible. And it is likely that winter retting requires less labor because the dead plants pull easily out of the ground without even the need to cut them, which often results in fiber wrapping around machines and blades. And it also does not require specialized hemp harvesting equipment. So that is like a huge draw to it. And there may be some soil health benefits also to leaving the plants standing dead, but there's no research on this to my knowledge, and it would be really tough to control for an experiment there. And in a moment, we will hear from Maciej Kowalski, who in fact utilizes winter retting in his protocol. Maciej is the founder and CEO of Kombinat Konopny, which is a hemp company based in Poland. Kombinat Konopny is a vertically integrated hemp operator working in both the herbal and fiber division. And in 2014, Maciej was granted the first private license issued for hemp in Poland. And after we hear from Maciej, we'll hear from Cody Ley. Cody is a Michigan-based farmer and founder of Hemp for Humanity. He has an educational background in chemistry and a diverse experience in the cannabis hemp industry, ranging from cultivation to processing. Cody started Hemp for Humanity with a goal to provide plant-based housing solutions that are built in cooperation with the natural environment. So sit back and enjoy these clips.
I'll also say that there's a small, just like 10 seconds around the 13-minute mark where there's a small issue with audio, but it resolves itself and then the rest of the video is fine. So don't worry if it sounds weird.
So we're here joined by Maciej Kowalski. We just learned that you received the first hemp grower's license in Poland in 2014. So can you give us a synopsis on your hemp journey through time since then, both growing hemp and producing finished hemp products?
Yeah, welcome everyone. It was indeed 2014 that I got the first license in the country to grow hemp as a private entity, because before that it was only licensed to public universities or wherever, at least in the nowadays, because back in the 60s, 70s, that was a very popular thing. But that was not the beginning of my hemp journey. I started actually 10 years earlier in 2004 as a marijuana advocacy group or whatever, because if, as you might know, possessing any amount of marijuana is still punishable with 3 years in prison in my beautiful country. It's still the case. So I wanted to grow hemp to somehow open the door to marijuana legalization, which was one of the reasons why people were telling, well, we should not allow people to grow hemp because they're all drug addicts. But then at the end of the day, I realized it's actually a very useful plant. So 2014, I was not realizing that one day I will be wearing what I'm growing, as Laura is actually wearing.
Me too.
Yeah, I wouldn't believe myself back then, but yeah, 2014 was the very first year of actually. Well, 2015 was the first year we actually started growing. 2013 was the license, which happily coincided with the whole CBD boom in your country, which helped me a lot because the US wanted to buy CBDs, but they weren't able to grow it. They didn't want to buy it from China, so they were left with European producers, and Poland has a big history of hemp cultivation. We have very tight Polish community in US. So it actually helped me a lot at the early stages. And 2014 until 2018, just to wrap it up very quickly, I was involved solely in the herbal part, which is basically CBDs, but in the European understanding of that, meaning natural molecule produced by the plant, not your gas station weed, whatever. We don't have that here. We don't want that here. So I was just producing those natural extracts from hemp, and then we sold a company to the Canadian holding that later bankrupted. And in 2019, being bound by non-compete clause, not being able to do what I know how to do what I love, being hemp cultivation, I was looking for the way to utilize my knowledge and my experience in hemp cultivation without infringing the non-compete clause in the CBDs. So I said, well, hey, there's fiber. Hemp, the official name for hemp in Polish, in my language, is konopie włókniste, meaning fiber hemp. That's how we call non-narcotic hemp. It's fiber hemp. So the fiber bit is like ingrained in even in the name of this plant. So not knowing a single thing about fiber, I decided to build a company that will one day be making socks. That was the idea, 2019. Half a year ago, 2025, I finally started wearing my own socks. Laura haven't had the chance to wear them yet, but I hope one day it's going to change. I would love to send it, but you've got those tariffs that are not very welcoming, unfortunately. But yeah, it's going to change one day. So yeah, I hope that answers your question.
Yeah, thank you so much. Okay, so this class is all about growing for end use. So are you able to share with us some of your planting specifications, such as what varieties you use, your seeding rates, and the row spacing that you use?
Well, the very thing you asked in that question is the most important thing that people have to remember. Even if they don't forget, even if you guys forget 90% of what's being said, the end goal is the most important thing you need to understand and know before planting the single first seed. And I obviously didn't know that before growing. So I see a lot of failed growers, failed entrepreneurs saying, well, let's grow 100 acres of hemp and then we'll see what's going to happen. Well, I can tell you what's going to happen. You're going to fail 99% of the cases, because if you grow a variety destined for flowers and you want construction materials, it's not going to work. There are some universal varieties, meaning they are possible to grow for everything, but they're not perfect for anything. So if you want to have flowers, seeds, construction materials, and textile fiber, it's best, instead of growing 100 acres of universal variety, just choose 25 acres of the variety that was designed to this specific use on 4 plots of land. Whenever I'm speaking of acres, we grow much smaller plots of land than what is used to be happening across the ocean. I'm growing less than 100 acres altogether, but I'm making more revenue out of those 100 acres than a decortication facility will make from 1,000 acres, because I'm making the end product, and the end product is the clue. I'm also making the herbal products, but we'll not be talking about that. Laura asked specifically about the textile varieties. We are limited to use only European varieties. I'm not legally allowed to grow Australian varieties. I'm not legally allowed to grow Yuma, which grows perfectly in Poland, which would be like a perfect variety, both the Australian and the South Chinese. Just think about the globe for a second. I'm located at 55 north latitude, which is even further north than Vermont is on the map of the United States. I'm closer to Edmonton. So obviously it's a little bit changed climate-wise, latitude-wise to the US, but we're getting below 0 Celsius, below 0 Fahrenheit in here right now, and that's good. For me, that's perfect thing for the cultivation, because we are growing dense, tall varieties that I want to be late blooming varieties. And now your mind might be going crazy, like, why? Late blooming varieties are destined to be grown in southern latitudes, because otherwise they will not be able to mature. And that's precisely what I want what I want to happen. I don't want the plants to mature because usually you might hear or read that growing for fiber means cutting down the plants before they start to mature, correct? Or you can do it the lazy way, the Polish way, just grow late blooming varieties that were designed to, like, design is not the proper word, but you know what I mean. Should be growing in southern Italy or should be growing in Texas, but I'm cultivating it in Edmonton, in Poland. So they, by middle October, they only start thinking about blooming, but the next week frost is coming. So it's just it kills the plant, and it allows me to harvest them in spring. We'll probably talk about harvesting and winter retting afterwards. So I'm planting it not very densely. It's 25 kgs per hectare, which is approximately the same in pounds per acre. So around 25 pounds per acre. We use pounds per acre or kilograms per hectare in Europe because most European varieties have the same size of seed, which is approximately 14 grams per 1,000 kernels. I've seen American farmers, or generally global farmers, using rather the idea of number of seeds per acre because seed varieties can be very small and some of them can be 2.5 times bigger. So 25 pounds per acre. I cannot do the quick math in my head right now, how much pieces per acre that is, but it's generally speaking lower. What I'm using is much lower than the generally accepted rate of sowing for fiber hemp, because usually the guidelines come from the seed manufacturers. And obviously their interest is for you to grow as much as possible, to use as much as possible of the fiber, but of the grain. But I don't really see the influence neither on the yield nor on the fiber quality. But what is very important to stress out, I'm using only cottonized fiber. I'm growing it for short fiber. So I don't really care that much about the thickness of the stem. If you go after long line fiber, as Laura is doing experimentally in her workshop, then you probably would rather have a higher sowing rate. And I will just pause for a while for Laura to also have her chance to speak.
Yeah. Okay. So that leads into, a couple of my questions. You've never seen, you've never had a problem with the plants growing too big for your end use?
No. Not really. I mean, before, when I was harvesting the flower for herbal products, yes, hell yes. But for fiber, not really. I mean, we're growing plants that go up to 5 meters, which is 15 feet or something like that. Right now, I prefer to keep them 3 to 4 meters, so around 12, maximum 14 feet. But it's not about the ease of harvest or processability. Even though we don't cut the stem into pieces like they do in Nebraska, Kansas, Montana, we just process the whole stem. It doesn't really pose any question on our processing line, and that's a very important emphasis, that you want the plants to be harvested in the way that your processor wants them to be harvested.
For sure.
Because the way I'm harvesting my plants, it will not work on someone else's. Essentially, it's always about the first bit of the equipment. So in our case, it doesn't really matter, but I chose to grow them a little bit slower due to nutrients uptake. In order for the plants to grow 6 meters tall, you need to feed them a lot of nitrogen. It's just sometimes better to have a little bit more acres with a little lower yield. It's not a contest who is gonna grow the biggest, the tallest hemp, but it's not a question of processability.
Okay, so one more quick question, then we'll get into winter retting. Have you ever seen pest or disease cause an issue for your crop?
Not really. Again, growing for fiber is much easier than growing for flour or food products, because some of the diseases that might be detrimental for the quality of food grain are affecting our plants, but I don't really care about it, because by the time I'm harvesting, the flowers are long gone. Even if there was some mold in the flowers, I don't care, because I'm not harvesting the flower, and it doesn't affect the the fiber in any way whatsoever. So the total acreage of hemp in Poland is rather low. We have around 25 million acres of land for farming, and out of that, maybe 5,000 acres are grown with hemp. So it's not a very common thing. Even in the glory days of Polish hemp, it was maybe 100,000 acres, even less than that. So still not a very popular plant. So we don't have this pressure of possible pathogens influencing one field to another or being perpetually the same field. So I have personally not witnessed that, but it's also maybe the weather conditions during our winter. It basically kills off everything that lives, including some of our humans. And probably the question of how many people are growing it. So it would probably become an issue, like in France, they have that problem because they're growing in the same county forever.
That's totally good.
All right, we'll just keep going then. I really want to talk about winter retting with you and hear about what inspired you. Because did you start not winter retting and then made the transition?
Well, essentially, I started as a flower manufacturer.
Right.
So I was after the flower. And the very first season, 2015, we grew around 200 acres, managed to harvest less than half of that. And then the rest was just left in the field. Like come November, the flower is long gone. And then like I sort of forgot about it. And come spring, the farmer is knocking at my door and saying, Mr. Kowalski, I want my field back. I want to be growing wheat again or corn or whatever. And you have this like dense forest of your hemp stalks. So what are we going to do about it? So I asked for the easiest way to just clean it from the field. I wasn't thinking about it as a yield, as a value. I was just like thinking about how to make good on the promise to give the farmer the land back. And then just baled it, raked and bale, which became like my signature technology. So it's like a total accident because the plants become very brittle at the very bottom. And the key thing is not to do absolutely anything in autumn, in fall or whatever you call it. Just keep them standing. Don't try to windrow it, because if you windrow it, then they just fall on the ground and then they got extremely overrated and close to unusable. If you keep them standing, 95% of the stalk length is usable for fiber. It is going to be slightly on the overrated side, but for my use, that's perfect. It actually makes the fiber a little bit weaker, but also a lot softer. And on the very bottom, like bottom 2 to 4 inches, are completely destroyed by the elements. So if you use the rotary rake, the easiest, the simplest thing available in every single farm all across the world, you just rake it into a windrow and then bale it. I just recalled one important addition to my previous answer on the sowing rate. We try to sow them as dense as possible, which is the usual way to sow grain in Poland, which is 4 inches. When I was touring the States, I heard that that's an incredible thing in the US, and they only use 7-inch drills. So if you have the possibility to buy something maybe from Canada, Mexico, or Europe, whatever, to have the 4 to 5 inches drill, that's way, way, way better than putting a lot of dollars into grain to put more seeds but still have them at 7 inches. That's ridiculous. Mm-hmm. So going back to winter retting, we just baled that material, and then back in 2015, I wasn't thinking about fiber. I didn't really care about that part, so I just sent it to a factory in Germany, which was making fiber insulation out of it. And they said that was the easiest straw they ever worked with in terms of decortication. Because usually when you harvest it in autumn or summer or whatever, you do some dew retting, but it's never perfect. It's never complete. So you need to put a lot of energy to separate the bast from the inner core, and it's still never perfect. You spend a lot of energy and you get very a lot of sheaves still attached to the bast, and however much energy you put, it's still attached because it's still glued together. After winter retting, the glues are completely dissolved, so the decortication process becomes much easier. So when back 2019, when I started working with fiber, I recalled that idea and we started working this way. You've been asking whether I started doing it the normal way and then changed. On the opposite, I started doing it in winter retting. Then I said, well, let's try to do it the proper way. I tested like a couple of dozens of different agrotechnology, harvesting, variety selection, time preferences, etc. And still, after all those tests, the original one was the best. And in terms of practicability for the farmer, because I don't expect the farmer to pay extra money for dedicated equipment. I know there are some the triple or 4-bar cutters in the US gaining popularity. I don't really see that happening in Europe, that I go to a small-scale farmer and say, well, for those 20 acres that you're going to grow, let's buy a piece of equipment for 100K. Not going to happen. But if you ask them, well, can you just make 20 acres and then just rake and bale it whenever it suits you, that's much easier. And for me as a processor, as a decorticator, this fiber is much better because it's easier. And for me as a spinner, so basically the guy that's making the yarn, for those that don't know what that means, it's also easier because the fiber is less stiff. And the stiffness of hemp fiber is the main obstacle for it gaining popularity in the textile world. So it works on every level.
All right, I have 2 more questions for you. The first one, I'm just thinking, like, do you find, I can imagine that since you said you're working about just under 100 acres across multiple farms, that it's easier to get consistency amongst all those farms doing winter retting, because I can imagine field retting would be all over the map with microclimates and whatnot.
Well, it's microclimate is the same in all of the fields because they're all located within like 15 miles from our facility. But yeah, to some extent, winter retting is sort of canceling all the errors of the farmer. But mainly, dew retting is just not possible in our climate. We are located below sea level. The ground is like a giant sponge. It's just constantly wet. So if you put anything on it, it's gonna be wet. Like retting, etymologically, should mean that it gets the dew in the morning, and then during daytime it gets dry again. So wet, dry, wet, dry. I can achieve that on the standing plants because they like it's raining and then it's windy, so they get dry and wet and dry and wet. If I put anything down on the ground in my area, it's just gonna decompose immediately. So it's not about being better, it's the only way possible here.
Okay. Okay, so my last question is, I think a lot of us in America feel somewhat of like a paralysis over the lack of domestic supply chains. And I'm wondering, as a Polish man who's never been living in that paradigm, what advice you have for Americans looking to see the hemp industry get off the ground.
You've actually got all of it. You've got the whole supply chain. You just don't know it. That's my impression. I've been to your beautiful country several times, and I've seen farmers. I've seen decortication facilities, and then on the cotton side of things, there's everything else. It's just the cotton guys don't like to speak to the hemp guys, and that's it. I mean, it's just enough. At the NCSU at North Carolina State University, you've got everything you need to process your hemp fiber from the decorticators into a finished yarn. We don't have cotton industry in Poland, so I was, because cotton doesn't grow in my climate, so I was relearning all of that from scratch. And actually having some base knowledge is an obstacle to making something new, because the cotton guys, if you approach them with your hemp, they're just going to look at it through their cotton eyes and they're just going to see poor quality cotton. And they was like, that's rubbish. We don't want it. I'm absolutely 100% sure that it is possible because I'm doing it on the sort of equipment that I've seen in the States. Maybe another obstacle in the US is thinking about thousands of acres before thinking about making a single pair of socks. What's the point of making a million of acres if you're making just decorticated fiber? No one needs decorticated fiber as the end consumer. Like maybe Laura does, or maybe me, but not regular people. So if you're a consumer and you've got 330 or 350 million consumers in your country alone, think about what they need: hats, socks, jumpers, whatever, or mattresses or duvets or whatever products that are made with other fibers, and you can make them out of hemp, including every single piece of machinery that you have already in the US. And also, if you've been thinking about what I said about our climate zone, that okay, this guy is doing it far up north from the perspective of someone. I don't know if it's only people from Vermont listening to that, or from all over the country, but you can do winter retting in Southern California, in Arizona, in Texas as well. I've been to the fields that were also left as a mistake in Central California, someplace in Texas Panhandle or Oklahoma Panhandle, I don't know, in places in Georgia. They've been leaving their plants for the winter, not specifically as a winter retting technology, but it works as well. I don't know why, because I always thought that it's water reaching the freezing point, expanding a little bit, separating the fiber into individual fibers. Maybe that helps, maybe it doesn't. I don't know. I'm a simple guy. If something works, then it works. Then I don't need to understand why. So it works a lot in every single place I've been to, from Montana to California to East Coast. There is a guy in Missouri doing hundreds of acres of winter retting, and it works. So you can do it.
Great.
You've got, you can.
Maciej, thank you. This was amazing. And we look forward to talking with you more.
Yeah, always welcome.
Cody Ley, thank you so much for joining us. Can you tell us who you are, about your mission with Hemp for Humanity, and how you began working with hemp as a building medium, given that it's a non-traditional material?
Yeah, so my name's Cody. I'm the founder of an organization called Hemp for Humanity. And I started on this journey back in 2020, 2021. When I graduated college, I was studying biochemistry and environmental science, and I learned about biocomposites and bioplastics and how hemp could be used for those things, which sort of got me really interested in how it could be used in the built environment. And so when I graduated, I wanted to learn how to build with this material, and I wanted to, have a career in building with natural, healthy homes, but nobody was growing it. And so in 2021, I started leasing some land as kind of like a side thing, and just got in there firsthand. I took the long way around and started to learn how to actually farm the material on just small 5-acre plots. And so we were doing variety trials for a couple years with the Midwest Hemp Research Collaborative. And then in 2024, I was fortunate enough to get a contract to scale up our farm some more. And at that point, I scaled up the farm, and I kept traveling around the country and learning how to build with the material. And then, yeah, it kind of led us to where we are now. 2025, we did some more projects and some more research on the farm. And then now 2026, Hemp for Humanity, really the goal is to take all that information and knowledge that I've learned over the past few years, kind of going from the ground up, from farm to frame, and turn that into a program that can empower underserved communities, where we can build affordable housing and also teach regenerative industrial hemp farming practices, as well as natural healthy home building techniques. And so that's where we are at now in Detroit with H4H.
Very cool. Can you talk about some of the properties or advantages to building with hemp over conventional materials?
Yeah. I think first and foremost, I think the the human aspect of the materials is one of the primary benefits that I've learned. Is just how we can bring the local, we can bring the means of production for our building materials back locally. I think that's one of the biggest benefits that affects not just the built environment, but also like our natural environment and our economy. I think that's the number one thing I think that is the biggest benefit of hemp. But uh, but besides that, there's also it's a very healthy building material, so it's very resistant to mold. It's resistant to pests. It can be built in ways that make it highly energy efficient. And yeah, so it's all natural, no VOCs, and it does create a very healthy indoor air environment, which is what I've seen from experience in the past couple of years for sure.
Yeah, I was really surprised. I learned on one of your other talks, you were saying that 40% of existing housing stock is a health risk. So
Mhm.
right there, there's a reason to build with hemp.
Yeah. Yeah, I think that the classic ways that we build is to keep, moisture and air out of the indoor airspace, but eventually water gets in and we're left with a degrading housing stock where we have to remodel it at the very longest after 30 years, or tear down and rebuild. And so I think that the resilience of natural buildings are much better than the plastic and styrofoam buildings that we've been accustomed to.
Hmm. So what varieties have you experimented with, and which have you found to be the most conducive to growing for building material?
So we've done a lot of varieties. I would say probably over the past 4 years, probably 20 plus varieties over the course of the 4 years, just in different applications. So like broadly speaking, I would say um, the best crops for building materials are going to be late flowering, um, late flowering varieties, and maybe even the the monoecious varieties where we have, each plant has just um, the one sex trait. I would say that those tend to put on bigger stalks, higher biomass in the actual stem. And I think that's what's more conducive for an abundance of hurd on your biomass harvest. I think that the grain varieties you can still definitely get building materials on, and there's, all over the country, building materials do come from grain crops or earlier flowering varieties. But I would say that, if you look at the ratios of what's coming out the other side of the decortication unit, the late flowering big, typically Asian varieties are putting on a lot of stem biomass.
Yeah, that's what I was thinking, but all the Asian ones we've worked with are dioecious, I think.
Oh, really?
Yeah,
Interesting. Okay. Well, I'll have to send you some of these that I was working with here.
but they're certainly the biggest and the latest flowering here in
Hmm.
Vermont in our climate.
Yeah.
So just on that subject, like what kind of stands are you said you're looking for height, so like the bigger plants. Is there anything with density, or can you share with us details such as like the seeding rates or row spacing that have contributed to optimizing your yield?
I mean, I can just even say from last year while I'm looking through this, like when we were planting, we were typically planting the grain varieties at a lower density and or no, opposite. We were painting the grain varieties at a little bit of a higher density, and we were going about like 55 pounds per acre, I believe,
Okay.
on the ones that we were growing for more biomass. Uh,
Okay.
yeah.
Hmm.
So anywhere from 35 to 55, I think, yeah, the grain varieties we were planting at a little bit of a higher density, and then yeah, depending on the variety, like we were anywhere from 45 to 55 for the biomass varieties.
Got you. So what is the harvesting, retting, storing, and processing protocols that you employ when growing for building material?
Yeah, so for the past couple years, we've been harvesting with a triple bar sickle to knock those down. And then the Retting here in 2024, we did some Retting trials where we baled up some hemp every 7 days after harvest, up to 28 days. And I think our sweet spot was somewhere in that like 2 week range, like the 12 to 14. It seemed to be more easily liberated without having too much of the black and discoloration from the decomposition. So from anywhere from 10 to 14 days is what I would suggest, but it varies pretty widely based on your soil moisture and what the weather is like. And so I think that's one of the biggest pinch points in the industry where we really need to figure out, the ideal protocol to be able to do this really efficiently and standardized. But there's only so much you can do. So yeah, we would typically cut down with the sickle bar. If the moisture permits, we would come through and flip our windrows after, 5 to 7 days, after a week. But in some seasons, it's been so dry that we didn't really even have to do that. And then we'd come through and bale, like I said, after about 2 weeks. And then we have a small, I guess, like man-made decorticator that we made from some farming equipment. One of our neighboring farmers had built it out, and it works really well to kind of like decorticate all the material that we need. It goes at about like 400 pounds an hour. So it's not the most like fancy nuts and bolts thing, but it works.
That's very cool. We're very familiar with homemade equipment too.
Yeah.
Um, on that note, can you talk about some of the most important specifications for the herd material, like such as the cleanliness, meaning like free of bast material, the
Yeah.
size, the retting degree, and then anything else that I might not know of
Yeah,
that's
typically,
important?
yeah, I think that, size distribution is definitely one of the most important. You want to be anywhere from like a half inch to inch and a half particle size distribution, with mostly hanging around that 1 inch size for your herd. Um, Anything more fine, you'll start to use a little bit more binder. It'll be a denser mix. And then anything on the chunkier side, your binder might not have as good adhesion as you want. And so I would say, yeah, anywhere from half inch to inch and a half, even down to a quarter sometimes. And then you want it to be pretty dust free. You want less than, 5% fiber in there because the fiber will just suck up moisture and create these little clumps. Um, and and then with the discoloration, I think this is something that's kind of overlooked in the industry, but it's super important because of the retting process. A lot of hemp, either just the way the industry's been, a lot of hemp will be sitting in storage for long periods of time, or it'll be over retted. And you'll know this when you get your material and you have a pretty high percentage of like discolored herd. So like it'll be dark, um, like blue or black little herds in there, and the higher percentage you have of those, the more likely it is that you're going to have some sort of mold failure in your installation, which I've seen a few times over the past few years, because I think we get this idea that, hempcrete is mold proof and it won't mold, but that's really the mold resistance comes when it's carbonated and it's fully cured. But when it's wet, the pH of that lime it still isn't super high, and what you have is a soggy biomass. And so if you're really inoculating your wall with high percentages of mold or microbial life from the retting process, then you're just putting yourself at a higher risk, over that, 6 to 8 week period of drying and curing for that stuff to kind of mold and spread.
Wow, yeah, that sounds pretty crucial.
Yeah.
Um, so speaking of the less than 5% fiber material, you must be left with a lot of fiber material at the end of this process. What do
Yeah.
you generally do with that byproduct?
Yeah, right now nothing. So, yeah, I think over the past years we have no use for the fiber right now. We've tried putting in different samples and different ratios and sent off to different suppliers and done some stuff with that. But yeah, for the most part, it's been disposed of and composted. Yeah, especially like on the research scale. But and I think the ratios that we were seeing from our later flowering varieties, um, we were seeing, coming off the field, usually around like 25%, anywhere from 20 to 30% hurd, and then another like 40% of fiber, and then the rest was like dust. Uh,
Okay.
so I think that could also change a lot depending on the processing equipment that you have. Maybe some more sophisticated equipment would have less dust. But yeah, we were typically seeing a little bit less herd and a little bit more fiber, um, but that definitely changes a lot depending on the variety too.
Hmm. So where do you find that you rub up against supply chain gaps in your industry?
Yeah, I think right now the supply is pretty good. Oh, like we have a quite a bit of hemp out there just from the past years and nobody having markets consistent for it yet. At the beginning, it was definitely there was not a lot of hemp herd out there, and it was hard to get. But now, I mean, specifically in Michigan, we don't have any large scale local processing, so that's the biggest thing. I think there's plenty of hemp out there. We have just here in Michigan, we have almost 100 tons of hemp sitting, waiting to get processed. And so I think um, really having the end markets really built out is really important for the processing to want to set up. And that's kind of the goal with what we're doing. We're kind of working both ends of the supply chain. We're trying to help farmers and educate them and create markets. At the same time, on the back end, working on the finished product goods, creating a demand for housing and really proliferating this building material so that we'd have more demand. But building materials are only a small portion of the industry. We definitely need the more sophisticated fiber and uh, micronized herd markets to kind of pick up to really facilitate a sustainable facility. Uh, yeah, so I guess processing, long story short.
Yeah. Is your closest facility out there Tiger Fiber in
Yep.
Missouri?
St. Louis,
Okay.
yeah.
Hmm. So since you're working with you're educating a lot of interested parties, what do you identify as the biggest barrier stopping other people who want to be a part of the hemp building industry? Is it the same for you, or does education or just lack of knowledge, or even barriers to land come up too?
Hmm. I would say, I mean, I think the farmers on the supply side, I would say the farmers will grow it if they can make money on it. And there's just not a lot of ways to make money on it right now. So I think the end markets being developed is like the number one barrier. And then in terms of like the building material space, yeah, I think that lack of knowledge and information is a big barrier because if we want to really attack the housing, crisis and the shortage of housing that we face, I think that we need to be looked at like a mainstream material that people can just order off the shelf and put into houses without a bunch of different complications or modifications. And so I think that creating systems of prefabrication or or just construction protocols around the material will make it a lot more accessible. And the education is a big point of that. But yeah, I think that at the end of the day, we just don't have the scale that is needed for people to make money competing with the feedstocks. So like in 2024, we grew for paper and it costs us about $200 a ton. And we're competing with a feedstock that they're conventionally using for paper at $80 a ton. And so there's just a large gap there that would come with scale, but it's just a matter of like certain companies taking that like who's going to take the hit, at the very beginning. And so far it's been the farmers and the farmers
Mm.
who try it don't make a lot of money and then they don't try it again. And so um, that's kind of what I see as a big roadblock to the industry taking off.
Mm-hmm. Okay, I have one more question for you that kind of dovetails with that one nicely, but what are some of the possibilities for this industry that you foresee in the future? For example, like, do you see a path where like the cost could decrease for these materials, or mandates that would prohibit the use of conventional materials that hemp could replace?
Hmm. Yeah, I think that one thing that I'm really excited about is the research that we've gotten into these past 2 years with the nonprofit, and that's phytoremediation. Because with this, I've got really excited about this because I think the barriers that we just talked about, like economies of scale and the need for processing, these could all be bypassed if we can create a market for the hemp that all it takes is to grow the hemp itself, right? So like across the US, there's millions of contaminated acres, whether it's PFAS or heavy metals or PCBs or other persistent chemicals. And hemp is a powerful phytoremediator. And so if we can find ways to come in and clean soil, this is a $1 billion industry for remediating soil. And typically it's done by, for example, in the PFAS realm, they'll come in and they will dredge up the soil and they'll take it to a facility and they'll clean it and then they'll backfill in the land, right? And so like this is a super inefficient process and it's super expensive. And so if we can get farmers paid for growing and cleaning up land, and that's all that it takes, I think that's a way that we could start to produce a lot of material and kind of break that like chicken and egg scenario where we can reach the economies of scale without having the just all of a sudden magical buyers at the end of the supply chain, right? And so the research that we're doing right now is building on our last year's studies around PFAS remediation. And now we're taking this material off the farm and we're learning what products can we make with it? How can we liberate the contaminants from the hemp to make it a value-added product at the end of the day? And so I think that this could be a really good pathway just for farmers to make money, up to $2,000 an acre just for planting the hemp. Then they don't even have to do anything on the back end. So, yeah, I think that's one
Yeah,
way.
the uses of hemp are really limitless.
Yeah, right.
Well, thank you so much for joining us, Cody. It was wonderful to hear from you. Okay, hi everyone. We are back for your questions. Thank you to our two guest speakers. Those were wonderful. And I see that we have a hand raised, so that's really exciting. Catherine, would you like to share your question?
Yeah, I just want to thank you all so much. This is such a great learning opportunity. Is Cody still with us? And if not, that's okay. Maybe you can
Yeah,
you know.
Cody's here.
Okay, great. So I specialize in fiber clay wall infill systems, and it's called Lamebow. And if anyone's interested in getting the compendium I made, I'd be happy to send that to you. And when I started, we only used straw because straw was like the waste industry in California. And then in Oregon, we used wood chips because wood chip was the waste product. But really, what you're storing is whatever fiber's available. And so I have a project coming up in New York where we're going to be trying to work with some of the material from Larry Smart. But my question is this, like, do do is there a way that we can not separate the herd from the stalk and have it in the 4 to 5 inch length with the lignins? Because that would be, it's like having little bits of rebar in your wall if you keep it all intact and it has the strength and the integrity. But right now, if there's only waste product, that's coming out of the processing, great. But I don't need it. I don't need hemp to be grown for herds specifically. And so I'm trying to say, sort of piggyback a little bit what the first speaker said is, I'm not sure we know how to use the materials that are already here, right? That can come right out of the fields in a dry form. They could go right back into building walls that are non-flammable, and I could go on. So that's my question.
That's really interesting. I certainly don't have experience with building or using hemp in that way. And Cody, I'm wondering if you have encountered any type of alternative building with whole stock, or just what comes to mind when you hear that question?
But yeah, personally, I haven't done any experience in building with the whole stock in the walls. I think when we talk about a very like, classical hemp mix, you know, the fiber and the herd they dry out at very different rates. And so, you know, in your typical IRC code accepted hempcrete, um, you know, that extra fiber in there can cause some issues in just drying out. But I'm sure, you know, a lot of that has to do with the actual matrix of the hempcrete binder and the material itself. And so if there are other, you know, innovative ways to build with the whole stock with different binders or different wall assemblies, you know, of course, yeah, I definitely think that's possible. Yeah, but I personally don't have any experience in working with
So
materials like that.
just to follow up, what I'm thinking of is the ease of production and the readiness and the materials that are already sitting around, right? So using clay, you don't need a binder because you have a wall system that will hold the material. It's just an infill material. It's your
Mhm.
insulation. So I just wanted to make sure that everyone kind of understood that. And so if in your work or with other farmers around, in terms of your point of growing bioregional materials and reducing carbon in transportation, and in my field as a designer, simplifying a wall system because you have your
Mhm.
structure, your insulation, and everything already there. I just want to say there's a possibility. And then when we come to like a clay plaster finish or lime plaster finish, we could also use smaller bits of the fiber then with the lignins to help that, to help that binder, right? Help it be a
Mhm.
binder. So there are lots of different uses
Yeah.
besides the ones that are currently being sort of pursued. And I just thought I would
Yeah.
share. Thanks.
I would agree with you there too on the plaster. I guess I didn't think about that. I was thinking about the wall infill, but in the plaster, we've definitely used hemp fibers as reinforcement there, and that definitely works nicely. So yeah. And if you need super sacks of fiber, just let me know. I'll send it your way.
Great, thank you so much for that question. Nan, would you like to share your question? Nan, are you there? All right, well, maybe Nan has stepped away, but we do have another question um, that's asking,
Sorry, I'm here. I was muted. I beg your pardon. I'm an idiot.
go
I'm,
ahead.
I actually had my questions in the chat. So, but I did want to know if there's any research on that PFAS mitigation because that's something that I'm trying to work on here in Maine because we've got some PFAS money to work with and wanting to do whatever I can do, using natural fibers to follow up on that, or if there's more research to be done. So if you have any of that, I would love for Laura maybe to share my email, and I'd love to see it if you've got some citations for me.
Yeah, we worked with Oakland University in Northern Michigan on that research and for all the analytical testing and everything. And then I do know there's some other companies across the globe doing it as well in Australia and Belgium. And so, yeah, it's definitely has a few different resources for citations for you.
I would so love that. Please, please, please. And the second question was, has there been any attempt to use some of the hemp products to as a material substitute for things like vinyl or fiberglass in windows or doors? Or is it mostly, I mean, they take a lot of a beating and so forth.
Yeah, there's definitely hemp composite building materials out there that are either structural or non-structural, just using different, you know, polymers and stuff like that. Um, and I could send you some sources for that as well if you're interested. It's not
I
typically
am
too common.
interested. I worry about all the glue and all the other stuff that goes into it, but
Yeah,
yeah.
yeah.
And I don't want to take any more time. Thank you very much. Sure, send me anything. Love it. Thanks.
Nan, I know of a project in Maine where you are of someone doing surfboards out of flax. It's like a linen textile they were sourcing from Australia, but
Uh-huh.
they can't anymore because of the tariffs. So they were looking for a domestic source. So yeah, there's definitely applications that are like fiberglass adjacent for our lovely bast fibers.
Great.
And we have so many great questions. We're
Yeah,
not
I
going to
want
be
to,
able
yeah,
to.
I'm backing off.
No, it's not just you,
Yeah.
but we're not going to be able to get to all of them, but just maybe one more in here that I see. It's Irma asking, when you're doing phytoremediation, can you still use the biomass for building material, or is it contaminated?
Yeah, and that would be highly dependent on what you're phytoremediating. And then that's what we're using our current funding to look into right now, is how to turn those, how to turn that contaminated biomass into usable product while also not, emitting a bunch of carbon. And so that's definitely what we're using our funding for this year right now.
Okay, well, thank you everyone so much for your time and our guest speakers. And we're just about out of time. So I just wanted to get to the recap from today. You're going to want to schedule your sampling event with your agent 30 days ahead of your scheduled harvest, or within 30 days of your harvest. Male and female flowers mature at different times, with male flowers expressing usually 2 weeks earlier than their female counterparts. Harvest timing will depend on end use. We went over all of that. Harvest method will also depend on end use. Hemp-specific harvesting equipment is not currently widely available in the Northeast. The goal of retting is to dissolve the natural glues that bind bast to herd in order to make their separation possible. There are many different types of retting. And most all end-use applications will require retting to separate bast from herd. Field retting will commence as soon as the plants are cut and laid on the ground. And winter retting, instead of relying solely on microbes, uses mechanical action to mechanically separate bast from herd. Thank you all for your attendance. It's been so fun doing this class with all of you, and all of your enthusiasm and all of your amazing questions. I'll make sure to go through them before our next week class. And next week, we'll be talking about processing and end uses. So we'll talk about the primary processing, cottonizing or woolenizing, spinning and beyond. And then we'll hear from Tim Holt and Cyrus Brooks, who we did a project with, making the first all local commercially produced hemp garments in the Northeast. And then we'll have our regularly scheduled Q&A. If you're looking for credits, you can scan the code here. And also please complete the survey, which will pop up on your screen when you exit. And thank you guys so much. It's been a joy, and see you next week. Thanks, Cody.